Oh, I'll try one. No. I'll just try one little bear here.
That is like this. Minus 2 is that is 2, but we can
Quite nice. You got your breakfast, Sean? You're ready to go?
That is very
Very healthy.
because most of the they like fish.
You ate?
We have to divide
You had something?
so that is
You didn't eat anything?
that is
But you'll be hungry. You can't concentrate.
we don't do
It'll be okay?
do this
Okay.
way, but we don't yes.
Okay, we'll continue now. Distance and area. Hey, come on. We'll continue now. Okay. So what we're going to have a look at now is some formulas for calculating distance and area between points and lines. So the first formula we want to have a look at so before I start, actually, just to say the main thing about this lesson is just looking at the formulas really. So the first formula is if we want to calculate the distance between 2 points, x1, y1 and x2, y2, and we want the distance here. So the formula to get the distance here is square root the difference of the x's, x1 minus x2 squared, plus the difference of the y's. Okay, so that's our first formula. So I'll write down all the formulas and then I'll do some examples. So if you can write this one down, this is the distance between 2 points. Okay. We got this one?
Yeah.
Yep. So let's have a look at the next formula. The next formula is the perpendicular distance between a point and a line. Question? Mistake? Question?
No, it's okay.
Okay. Right. Next now, let's say we have a point here, which we'll say is x1, y1, and a line here, which we'll say is ax plus by plus c equals 0, and we want this distance, this perpendicular distance between this point and this line. So this formula is d equals ax1 plus by1 plus c all over square root a squared plus b squared. And I'll just put these lines around it. I don't remember if I've talked about these lines. Yeah, did I talk about it or you just knew that? Okay, I don't think I talked about it. So as you said, this is called the absolute, which just means it's the x, but you make it positive. So for example, absolute of 3 is 3, absolute of minus 3 is still 3. And the reason for this is because distance should be a positive. Can you see now? KJ? Prove it?
Oh, wow.
Yes, I can prove it. Do you want me to prove it?
Yes.
Well, you'll have to wait until we do calculus. But yes, I'll prove it. But I'll tell you when to ask me that again. So let me just look at the lesson plan here.
Can you try proving it as equal understanding?
Huh? Well, no, I guess I could prove it now without using calculus.
We need a calculus.
No, you don't need calculus to prove it. Just make it easier. Okay. Let's just look at, if you wanted to prove it, how might you prove it? So if I go to the side. Okay, so the proof. So we have this line here, ax plus by plus c equals 0. We have this point here, which is x1, y1. Now let me just rewrite this as y equals minus a over bx minus c over b. True? So the slope of this line is minus a over b. So what's the slope of this line that's perpendicular to it? B over a. So I have y equals mx plus c. How can I find the c? Now this c is different to this one. How do I find this c? By using this point, yeah. So I'll put that point in, and I'll get y1 equals bx1 over a plus c. So c equals y1 minus bx1 over a.
Yeah.
And I can put that back in, and I get y equals b over a x plus y1 minus bx1 over a. And if I want to find this distance, I have to find this point first. So that means I have to solve this and this.
Isn't it 90 degrees?
Yeah, this one's 90 here, yeah. So I want to find this point here, is what I meant then, yeah. So I need to solve these together. So I should multiply this by a over b, and I should multiply this by b over a. Let's see what we get. No, actually I don't need to, because the y's are already the same if I minus now. So I get 0 equals b over a plus a over b x plus y1 minus bx1 over a plus c over b. So I get x equals c over b bx1 over a minus c over b over a plus a over b. Yeah. Then I can get the y. And to make it clear, I'll call this point x2, y2. So is it true I can get the y2? Yeah, I just have to take this answer and put it into, which will be the easiest one? We'll say this one here. So that will be minus a over b, that big thing, minus c over b. And then to get the distance, square root x1 minus that fraction squared plus y1 minus that one there. And then you just simply simplify, and in a few short steps you'll end up with this. Some stuff happens here, and this simplifies down to this. That's the boring stuff. It was everything else you wanted to see. That was the interesting stuff. Okay. The proof can be done a little bit quicker and easier with calculus, which we'll do later in the semester. Huh? No, because we haven't done calculus yet, so it'd be quite unfair. Okay. Next formula now. The area of a triangle, and the only thing I need to say is that this triangle, I'll put one of the points at the origin for the formula. So you have a triangle where one point's at the origin and the next ones are not. And what's the area here? So for these triangles with one vertex at the origin, it's a half x1 y2 minus x2 y1. Okay? No. Not yet? No problem. And again, notice the absolutes here, because area should be a positive. Continue?
Mm-hmm.
Yeah. Okay, let's have a look at some examples just to get started. So, the first example is I want the distance between 3, 2 and minus 9, 7. Okay, well, that's just using our distance formula. Square root x1 minus x2 squared plus y1 minus y2 squared. That's square root. This would be 3 plus 9 squared, and then that's 2 minus 7 squared. So what's that? That's 12 squared plus minus 5 squared. So that's 144 plus 25, which is root 169, which is 13. So 13 units is the answer here. Yep. Okay. Can I? No, not yet. Okay. Next example.
Yeah.
Next example. So the next example is the distance between 2 and 6x plus 8y plus 9 equals 0. So again, using the formula, it's absolute. On the top it's ax1 plus by1 plus c over square root a squared plus b squared. So that is absolute 12 plus 16 plus 9 over square root 36 plus 64. 12 and 16 is 28, isn't it? 28 and 9 are 37 over square root 100. Which, yeah. So, oops. So this is obviously then 37 over 10, which is 3.7 units. Yeah. Okay, I'll give you one like this to try, just make it a little bit different. Yeah? Okay, I'll give you this point and this line. And I want the distance here between the two. Okay, so you might have noticed a small problem with this. What do we need to do first here? You need to rewrite it, don't you? So this becomes 4y equals 3x plus 3. So it becomes 3x minus 4y plus 3 equals 0. Now I can take this with this. This is A, this is B, this is C. This is x1, this is y1. This is A, this is B, this is C. This is x1, this is y1. So now I can say distance equals absolute A x1 plus B y1 plus C over square root 3 squared plus minus 4 squared. So that's minus 9 plus 28 plus 3 over 5. What's that now? 22 over 5? Is it 4.4? 4.4? Okay.
That's a little 2 over 5.
You could, but both are acceptable because 4.4 is exact. You don't lose anything by writing 4.4. It's not like it was 1/3 where you would lose something. But it's fine to leave it as a fraction here. Okay, let's have a look at an area of a triangle now. Can I have a look at the triangle now? So, let's see, we have a triangle and we'll put 1 point on the origin, 1 point up here at 316, and the other point here at 1816. So it makes a triangle like this. Whoa. Let's try that again. And I want the area here. Okay, so the area is a half x1 y2 minus x2 y1. That's a half. What's that? 48, is it? And what's this, please? 6, 8,
288.
thank you. So that's a half of minus 240, isn't it? Which is a half of 240, which is 120. Got that? Yep. Yep. Okay. Can I scroll down? Yep. Now let me give you another one like this, but again, like last time, a small complication. So try this one now. So this is minus 2, 6. This one here is minus 7, 12. And then, I know this isn't to scale. This is 2, 1 here. And I want the area of this triangle. Now you need to think about what you can do here, because my formula I gave you, it only works when one of the vertices is at the origin. So now what do we do? So just to be clear, the 3 points are minus 2, 6, minus 7, 12, and 2, 1. Yeah, I need to think about what we can do. Minus 7, 12. Okay, any ideas on what to do to deal with this? Make a line, yeah? Yes.
actually that 2 points, and you can know that ABC points
No, this sounds complicated. I had an easier way. Anyone else? Yeah?
calculate the distance between -2x and
Nah, that sounds complicated. I have an easier way than that.
the line.
Yeah, this is what Jerry was saying. I don't know what this line is. No need for a line. Huh? Thank you. Move which one? Which? Yeah. So what you do here is you take this triangle and you just move all the points until one of them is at 0, 0. Yeah, so how to move them? Well, if you take this point, what would you have to do to make it become 0, 0? You would have to -2 and -1.
Yeah.
So you do that to all the points, and this one will become 0, 0. This one will become -9, -13, and this one will become -4 and 5. Yeah, and now you can use it on these two. So the area will be a half -4 -13 -5 by -9. So that's a half 52 minus 45. That's 3.5. Is that the answer you got? Was this easier? Jerry, did you get this answer?
I didn't have that.
Ah, okay. Yes? Ah, rats. Thank you. Made a mistake here. Guys, this should have been an 11 here. 12 minus 1. Let me just fix that. 11 here. So that means -4 multiplied by 11. So what's that now? Minus 44? Well, this is a totally different answer then. That's a half of 89? No, it's not.
Multiplied by -9 shouldn't be a positive.
Oh my goodness. It should be, shouldn't it? Sorry. And this should be a positive 45 minus 44. Well, I can do that one. That's a 1. And 1 multiplied by a half is a half then. Let me check the answer. No, I think either I'm wrong again here or my answer's wrong here. No, sorry, I was looking at the wrong answer. The answer's right. I just checked it here. It's right. How can I make sure?
Minus 2, 6 and minus 2, y.
Well, what I do is I pick one point and I make one point go to 0, 0. So if I pick 2, 1, then I should use -2, -1 to move them all.
Yeah, that's like minus 2, 6. You saw 6 is equal to y. If I that always more than.
Oh, my picture, it doesn't matter, my picture's not accurate. I know it's not.
But will you put that 2, 1?
I know my picture's not accurate. I know. No, I can see that because this 6 is here and the 1 is here, so it should have been more like this. But it doesn't matter, it doesn't change the answer. I know my picture's terrible because I know this is 1 and this is 6. I'm not an artist.
No, I mean that A is and A has under bracket.
I know.
And what do you know that is terrible?
I'm confused. What's your question? No. Is the problem my picture's terrible? Is this really the problem? I know my picture's really bad.
Even your picture is not terrible.
It's not? Oh, thank you. Yeah? So you're talking at this point?
Yeah, this one is entire.
Yes, I know this.
And
It should be like up here.
which is that into the 0, 0 and A can under I.
No, it doesn't matter which point you move to 0, 0. So even if this was up here, and you still move this one here, it doesn't matter where the other points are. So like, if this was up here, I could even move this, or this. I can move here. It doesn't matter which one. And it doesn't matter if any of these points are under or over the x-axis. That doesn't matter either. The only thing I care about is making one of them move to 0, 0. That's all that matters. Yeah. Okay. Can I scroll down? I'll give you one to try, which you'll need to think about. But before you try it, I just want to see if anybody knows this word. Collinear. So I would use this in a sentence like, these points are collinear. So does anyone know what that might mean? If I said these points are collinear. What is it? Same line, yeah. So if I say these points are collinear, what I mean is these points are all on the same line. Yeah? That's what collinear means. So now that you know this word, I want you to think about this question. Prove 1, 2, 4, 5, and 7, 8 are collinear. I can think of 2 ways to prove it. I want to see if you can think of any ways to prove it. So prove that these 3 points are collinear. Yeah? Huh? Yeah, but how would you write this down as an answer? You know, how would you explain this? So, let's hear any ideas. How could we prove they're collinear?
Prove the area of zero.
That's one way, and yes? Not necessarily, because if I have these 2 points with one gradient and these 2 points with the same gradient, they're not collinear. Unless, of course, these 2 are the same, which it is here. Okay, so we have 3 ways then. So the first way is you can show that the slope between the first 2, here and here, is the same as here and here. That's one way. Second way is you can prove that the area is 0, because if they're not collinear, you should have this. If they are collinear, the area here is 0. But I can think of a third way.
Prove that 4, 5 is on the line of 1, 2, 7.
Yeah, you can find a line and show they're all on this line. In this case, it's actually quite clear to see what the line is. It's y equals x plus 1. So you can verify all three are on the line. That's at least three ways I can think of. Can we think of any more, maybe?
Midpoint.
Oh yeah, perhaps perhaps the middle point is the midpoint of the two. That would prove it's collinear, but if it was false, it doesn't mean it's not collinear, because just because I have 3 points, it doesn't mean the middle one has to be exactly in the middle. So if it was true, it means you've proven it. If it's false, it means you haven't proven it wrong. Is it the midpoint here?
No.
Oh, it is the midpoint. Yeah, because 1 plus 7 is 8 over 2 is 4, and 2 plus 8, 10 over 2 is 5. Okay, so in this case you could actually do it by using a midpoint. Yeah? So you have at least 4 ways to prove it. I think in most books and most exams, typically this way they kind of expect, but I'm quite happy with you doing it this way as well. This way is quite similar to the first way, and I don't really like the last one because it only works sometimes, but it's still fine. Okay, can I scroll down? Yeah. Trying to think, is there any other ways? I don't think so. No, don't think so. Okay, so let me tell you which ones to try. I'll keep it easy. 1A, 2A, 3A, 4A, 5A. Huh? What's wrong?
Yeah, our net is actually Pascal's triangle. Yeah.
Oh, it's not in your workbook? Disgraceful. Then you'll just have to go onto Moodle and open it up then. It's on Moodle. Oh, do you know what? Actually, I'll put it on the screen here. How do I do full screen again? Too small? Too small, isn't it? Yeah. One more maybe.
This is 1A and...
The A for each.